This is the last example I'd like to give you from Chapter 10. The number of points scored by KU's men's basketball team in 2018 and Duke's men's basketball team in the first 8 games of the 2018 season are given below. At the alpha equals 0.05 level of significance, is there sufficient evidence to conclude that Duke scored more points than KU on average during the first 8 games of the season? So, when you look at a question from the very beginning, you have to start to decide, what of these tests do I want to use? So we fill in those steps in the middle, but really we could start to fill those in earlier if we wanted to. So for instance, we know here we have 2 samples. This isn't matched paired, right? There's not like there's the same grouping followed through. Looks like we have these 2 independent groups of KU scores and Duke scores. Now we're looking at means because we said on average, what's the difference? And we have to ask ourselves now, if we have samples and means, do we know the population standard deviation? Well, no. So we have an unknown population standard deviation. And so this automatically tells us that we're going to be doing a 2-sample t-test. But let's not forget that the most important thing we need for our hypothesis testing are our hypotheses. So we have our mu sub 0 is going to be, say, mu sub k is equal to mu sub d. So we have, say, mu sub k is going to be the mean of KU, and mu sub d is going to represent the mean of Duke. So our alternative hypothesis, we're wondering, is KU less than Duke when it comes to average scores? Now, if you want, you could also go back here and do a 1-tail test, just to indicate that. Now, if we go to our calculator, we go to stat. Now, notice we do not have all of our calculated statistics. So this is where we want to go in and edit them into our list. Now, because we have these 2 samples, we're going to enter in KU's data into L1 and Duke's data into L2. So in this one, I'm going to enter in 93, 70, 79, 92, 84, 89, 77, 87, and 90. Now in L2, I put in my 118, 94, 84, 90, 78, 87, 90, 113. Now, when we look at these numbers, we could build some intuition and say, oh yeah, Duke does have a pretty couple high-scoring games, right? 118, 113, they seem to be pretty big. Now, there's a couple of them that are less than KU, so we'll see how all of this works when we do the hypothesis testing. So we go down to our 2-sample t-test. We entered in our data. Now we put in list 1 as L1, our list 2 is L2, and our frequencies is just one of each of these. And now we're wondering, is the first group less than the second group? We do not pool our standard deviations or variances, and now we calculate this. So now we see that the test statistic, in this case, is t is equal to negative 1.47, and our p-value we see is equal to 0.0877. So now we can make our conclusion is that since the p-value is equal to 0.0877 is larger than 0.05, which is alpha, we do not reject the null hypothesis. There is not sufficient evidence. There's not sufficient evidence to believe that Duke scores more points than KU. Now, this is something where there's some pretty decent evidence. If we look back at the calculator, you have x1 bar is 86.375 and x2 bar is 94.25. Now, the major reason that we do not have a statistical difference there is because of these standard deviations. These are really large standard deviations, so we can't really chalk it up to Duke being significantly more high scoring than KU because we have such a large standard deviation. So this is something where collect more data, then you might be able to make a better conclusion on this, because we feel pretty good that indeed Duke does score more points than KU.